Hello, welcome back to three-phase circuits. We have our last Wye-Wye problem arrangement here, and I throw a little couple curveballs at you, mostly to get you to think a little bit. Also, probably one thing that you wouldn't have, I'm just going to teach you straight out. None of it is difficult though, as we will see. So the first part of the problem says we have a Y-connected source, and it has an ACB sequence, phase sequence. So first of all, you know it's a negative phase sequence. So get ready to do flipping around, you're adding and subtracting 120 degrees. And it says the source, this is talking about the source, it has an internal impedance of 0.02 plus J 0.16 ohms per phase. It says the Y-connected load is balanced with an impedance, and it gives you the impedance. And it says the line to neutral voltage at the load is 2400 volts. And it's also telling us to use that voltage as the reference. Then separately it says the line impedance is given by this. So it gives you a bunch of information. Obviously we have to write it down and assimilate it and draw it in the single phase equivalent circuit. We'll get to that in a second. But then we have to find the line currents, all of them, the line to line voltages at the source, and then finally something very bizarre that I haven't really mentioned so far, the internal phase to neutral voltages at the source. And I even tell you what they are: VA prime N, VB prime N, VC prime N. Now I'm going to kind of teach you what that is. It's not hard, it's not difficult, but it's something you'll probably see in your book. That's why I'm doing this problem. It's very much in line with what we've done. Don't get stressed out about it, but it's there, and I have to show you at least one problem that involves that. All right, so there's a bunch of things in this problem, a lot of which is set up to kind of just screw you up and give you another opportunity to make an error. The phase sequence negative, don't forget that. The source has an internal impedance which is given here. So a lot of times our problems haven't really involved a source impedance. So let's start drawing our single phase equivalent circuit to make some progress. So first thing is we have some voltage source. We don't actually know what that is, so I'm going to just leave it like this for right now. And now, though, it's telling us that the internal impedance of the source is given by this, 0.02, that's a resistive component. And then we have some inductive component. This is all a source impedance. And then we have some line impedance, which is given here. So I know that's a resistive and an inductive component of the line. So we have kind of a dot here. You know what I'm going to do? I'm going to have to draw a couple things in a second. So I'm going to give myself a little more space. And let's go over here and draw this line impedance here with the line inductance. And then over here, what is the load here? The load, let's see, this is the line. Where is the load at? The load is right here. So that's also inductive. So it's going to be like this, inductive, and then we're going to connect everything back together. So the only difference between this single phase equivalent and any of the other ones is that we have an internal source resistance. So this guy is going to be little a, big A, always as usual. That's always the same. So I'm going to call this little a, big A. And this is capital N, where the neutral comes together, where everything over on that side, and this is little n. So little n, big N, little a, big A. Everything's cool so far. Now let's go with the easier stuff, the line and the load. The line is given 0.1 and J 0.8. So let's go ahead and do 0.1 ohms and J 0.8 ohms. All right, and then we have a load impedance, which is, where's the load? I keep forgetting that. Here's 16 and J 12. So 16 ohms and J 12 ohms. So far it's really easy. And then we go back to the top and we see the internal impedance of the source is 0.02 and 0.16. So I'm going to write that here as, where am I going to do that? I'm going to do it right here actually. 0.02 ohms and J 0.16 ohms. So you got to remember that this inductor and resistor, it's kind of in a dotted line box. The source is kind of like all of this stuff is the source, right? I draw them separately because the voltage generator part is separate, kind of separate schematically from the actual impedance of it, but don't forget that this impedance is actually inside the source. So the way you would think about it is looking from the little a terminal this way, this impedance is wrapped up inside of here along with whatever voltage generator part of it is there as well. Okay? Even though I'm drawing them separately, envision it as being in there. Okay, what do I want to say next? How do I want to talk about this next? Let's start talking about our voltages. This voltage from A to N, capital A to N, we've been doing all along. It's V capital A, capital N, between there and there. And then the voltage from little a to little n, we've been doing all along. We'll call it V little a, little n, like this. Now, everything I think we actually have from the circuit in there, except for one little thing.